So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, welcoming you all to a new amazing video in which we are gonna talk about a crazy integral. And that integral you might have seen on the thumbnail itself, right? So I don't need to tell you about that. How crazy is that, right? We just have to evaluate that integral. Okay, before anything, let me tell you something. I have recently uploaded a video on the evaluation of this integral only with the other method. We did some manipulations in that video with that integral, right? Let me tell you the integral. So basically, we are just going to evaluate I equals integral 1 over 1 plus x to the 4 dx. So basically, we are just going to evaluate this integral in this video, right? Okay, so now what? Okay, I think I haven't started the recording yet, but it is recording. Okay, so basically, it's not easy to evaluate. Let me tell you let me tell you honestly that it's not easy to evaluate, right? But still, there are some ways by which we can evaluate this. And the first way I have evaluated, so if you haven't watched that video yet, please consider watching that video first and then come to this video, right? Because that video would be shorter than this one, I think, because this method is quite long, and I would say this is gonna consist a lot of things. So yeah, that's all. And so basically, I think we should directly jump into the integral, right? And I'll tell you what a Calc 1 student might think about this integral, or maybe integrand at first, right? Even though I thought about that, I thought about this, right? So let me tell you. So basically, we are going to talk about this integral, right? 1 over 1 plus x to the 4th dx. So whenever we see some sort of 1 plus x square or 2 plus x square inside the denominator, so we just have to plug x equals tangent theta, right? Or according to that, let's say I just asked you that assume that we have 1 plus x square, or maybe 1 plus 1 over 2 plus x square. So for this case, we have to just take x equals tangent theta, right? And for this case, we have to take x equals 2 tangent theta. And why 2? Because if you plug, or maybe I think square root of 2 tangent theta, right? And why square root of 2 tangent theta? Because when you plug here square root of 2 tangent theta on the place of x, so 2 plus the square root of 2 tangent theta whole square, right? So that is 1 over 2 plus 2 tangent square theta. And now you can just plug 1 over 2 out of the this part. So you would be having 1 over 2 and times 1 over secant square theta, right? So basically that is quite easily evaluable. So for our case, we can consider plugging x square equals tangent theta, right? So let's talk about this, and that is what I was saying that a Calc 1 student might think about this first. So x square equals tangent theta, right? So x to the 4th is gonna be tangent square theta. So it's pretty fine, right? And if you take the derivative, so that's gonna be 2x dx equals secant square theta d theta, right? So basically dx is gonna be secant square theta d theta over 2. X is gonna be square root of tangent theta. Okay, so now let's just plug all the stuffs back into our integral, and yeah. So this is gonna be 1 over 1 plus tangent square theta and secant square theta d theta over 2 times square root of tangent theta. So this is getting cancelled out with this one, and we are having 1 over 2 and the integral d theta over the square root of tangent theta. Oh my god. isn't that difficult to evaluate. Like just look at that. It's tan to the negative 1/2, and it's really difficult, I think. So we would not be just proceeding with this method because we can just do something better rather than this one, right? So let's do the one that we are here for without wasting our time. So we are going to do here, let's consider the denominator of our integral, right? So that is 1 plus x to the 4th. So let me tell you something here. We can write this as x squared plus 1 squared, and x squared, right, and whole squared plus 1 squared, and we can write this as, right, because eventually that's gonna give x to the 4 plus 1. And I'm just going to add 2x squared and subtract 2x squared as well. So basically it's x to the 4 plus 2x squared plus 1, and then minus 2x squared here. And this is, we can write this thing as x squared plus 1 whole squared. Be careful here. And if we talk about this, so this can be written as the square root of 2x whole squared. And now we have a squared minus b squared, that can be written as a plus b times a minus b. So this is x squared plus the square root of 2x plus 1 times x squared minus the square root of x plus 1. So this is the factor of 1 plus x to the 4th. So basically we are just going to plug this back into in our denominator here, and we will be proceeding with that respectively. So basically x to the 4 plus 1 equals x squared plus the square root of 2x plus 1 times x squared minus the square root of 2x plus 1, right? So let's just plug that back into our integral, and let's see what we are having so far. And so far you have guessed like what I'm gonna do from here. So I equals integral dx over x squared plus the square root of 2x plus 1 times x squared minus the square root of 2x plus 1. Now we are just gonna play around with 1 over x squared plus the square root of 2x plus 1 times x squared minus square root of 2x plus 1 with its partial fraction decomposition. So we are just gonna take a look at the partial fraction decomposition of this integrand, right? So we are having x squared plus the square root of 2x plus 1 times x squared minus the square root of 2x plus 1, right? And well, we can just equate it to ax plus b over x squared plus the square root of 2x plus 1 and plus cx plus d over x squared minus the square root of 2x plus 1. And we have to just calculate, we are just going to take a look for a, b, c and d respectively after solving that equation, right? So basically this is going to be 1 equals ax plus b times this part, that is x squared minus the square root of 2x plus 1 and plus cx plus d times this part, that is x squared plus the square root of 2x plus 1. And we just have to multiply these two things and these two things as well with each other respectively, and then we have to just look for the coefficients of x cubed, x squared, x and the constant terms, and we just have to compare that. So let's just do that right here. Okay, so basically let's just solve that here. So 1 equals I'm just going to multiply this ax plus b times x square minus the square root of 2x plus 1. So that's gonna give us ax cubed, right? And then minus square root of 2a x squared, and then plus ax, right? And if you talk about b, so it's bx squared minus the square root of 2bx plus b. And so for cx plus d times x squared plus the square root of 2x plus 1. So it is cx cubed plus the square root of cx squared plus cx plus it's dx squared plus the square root of 2dx and plus d. Okay, so it's pretty fine. And now we just have to take common of the coefficients of same look, what I'm talking about is we are having x cubed. The coefficients of x cubes are a and c, so we can just combine them. Actually, I have forgotten a plus here, so we can say a plus b x cubed. So the coefficients of x cubed is going to be a plus c. And if we talk about x squared, so it's negative square root of a, then plus b, plus b, and then plus the square root of c here, and plus d x squared. Okay, and now we're going to look for x. So plus it's a minus the square root of 2b here, and for here it is c, and here it is the square root of dx, and for constant we are having b plus d. That's it. So on the right hand side we are having a constant that is 1. So b plus d equals 1, and rather despite b plus d, all of them equals 0, because we are having the coefficients of x cube is 0 on the left hand side, so for x square and so for x. So from here we can say a plus c equals 0 minus the square root of 2a plus b plus the square root of 2c plus d equals 0, and a minus the square root of 2b plus c plus the square root of 2d, and that is also 0, and finally b plus d equals 1. So these four equations we are having so far after solving this partial fraction decomposition. And now we have four variables and four equations. So with the help of all these four equations, we are just going to look for the values of these variables, that is a, b, c, and d. So let's just take a look at them. So yeah. Okay, so we have a plus c equals 0, right? Okay, look. Look at this equation. So a plus c, right? A plus c is 0. So basically a plus c is gonna vanish, right? And we would be left with minus square root of 2b plus square root of 2d equals 0. Okay, and we have b plus d equals 1. So if we consider plugging negative square root 2 out of this, so we are having b minus d equals 0. So basically b minus d is equal to 0, and we have b plus d equals 1. So from these two equations we can say b equals d equals 1 over 2. Because when you add b plus d, that is 1 over 2 plus 1 over 2, that is going to give us 1. And if you subtract them, that is 1 over 2 minus 1 over 2, that is going to give us 0. So basically we have successfully computed our b. I think I should consider 1 over x square. Oh, wait a second. I think I have taken ax plus b over x square plus the square root of 2x plus 1, and plus cx plus d over x square minus the square root of 2x plus 1, right? Oh my god, I would have forgotten this. So that is why let me just consider writing it as something like this, and we have successfully computed b equals 1 over 2. Now let's take a look for a and c. So okay, so b plus d is 1, right? Yeah, so b plus d is 1. So negative square root of a plus the square root of 2c equals negative 1, right? And we are having a plus c equals 0. So from here we can say a equals negative c. So if you plug here, so it's gonna be the square root of 2c plus the square root of 2c equals negative 1. So if we solve for c, so c is gonna be negative 1 over 2 root 2. And if we want to add something with c, and that should be 0, so we would be adding the positive part of this part, that is 1 over 2 root 2. So 1 over 2 root 2 plus actually minus 1 over 2 root 2 from this equation, it is 0. So basically a equals 1 over 2 root 2 and c equals negative 1 over 2 root 2. So yeah, that much amount of things we are having so far. And now let's just talk about the two integrals that we have separated actually, for which we have did this much work. So let's just do that. So since I have considered my integral, that is 1 over 1 plus x to the 4th, as I, so we have I equals integral 1 over 1 plus x to the 4th dx. And from factorization of the integrand, we just saw that it is x squared plus square root of 2x plus 1 times x squared minus square root of 2x plus 1. Okay, and yeah, so from partial fraction decomposition we got to know that our I equals integral this part, that is ax plus b over x squared plus square root of 2x plus 1. So our a was 1 over 2 root 2x plus 1 over 2, right? And x squared plus square root of 2x plus 1 dx. And for our next part, it's negative 1 over 2 root 2x plus 1 over 2 over x squared negative square root of 2x plus 1 dx. Okay. Now, from both the cases, we can consider plugging out 1 over 2 root 2 from this one and negative 1 over 2 root 2 from this one. So basically, we are having since we are not having 2 root 2 in the denominator, so we have to multiply and divide with 2 root 2 for this part. So we would be having x plus square root of 2 here and x square plus square root of 2x plus 1 dx. And for this case, we have to plug negative 1 over 2 root 2 out of the integral, and this is x minus square root of 2 over x squared minus square root of 2x plus 1 dx. Now, we are having two integrals, right? And let's just evaluate them separately. So I would consider this as I1 and this one as I2. So we just have to write that down as well. So basically, I equals 1 over 2 root 2 I1 minus 1 over 2 root 2 I2, right? And yeah, so I1 equals integral of x plus root 2 over x squared plus square root of 2x plus 1 dx, and I2 equals integral x minus square root of 2 over x squared minus square root of 2x plus 1 dx. Yeah, I don't want to just forget that, so okay, let's just consider evaluating I1 first. So I1 equals integral of x plus square root of 2 over x square plus square root of 2x plus 1 dx. Now in the integral, I'm just going to multiply and divide with 2 here. So it's 2x plus root 2 plus root 2, since 2 root 2 can be written as 2 root 2 plus root 2, so that is what I have did there. And this is x square plus the square root of 2x plus 1 dx. Now I can just split this integral in two integrals as well further. So it is integral from, an indefinite integral, right? So 1 over 2 times the integral of 2x plus the square root of 2 dx, actually. X square plus the square root of 2x plus 1 dx. And the another integral, since the square root of 2 we are considering in the another integral, so that is a constant. So it is square root of 2 over 2, this factor, and times the integral of dx over x square plus the square root of 2x plus 1. Okay, let me just check whether the recording is yeah, recording is good and it is going on. Now look, this is crazy and this is really amazing. Okay, so look at the derivative of this part, that is the denominator of the first integral of I1. So if you take the derivative, so that is the derivative of x square is 2x, and the derivative of the square root of 2x is just a square root of 2, and the derivative of 1 is 0, right? So basically we are having 2x plus the square root of 2. And if we plug this as t, so we have 2x plus the square root of 2 dx as dt. So basically it's dt over t, an integral. So it's ln of t. So for our case, t equals x square plus the square root of 2x plus 1. So yeah, it is 1 over 2 ln x square plus the square root of 2x plus 1. Isn't that crazy? And that is why we just multiplied and divided with 2 and split it further, this integral in two parts. Now let's talk about this one actually. So the square root of 2 over 2 integral dx over. Okay, now let's talk about the denominator of that integral as well. So we have used this much stuff, so I think we should just erase this. Okay, so yeah, so we are having x squared plus the square root of 2x plus 1, right? Well, we can just consider adding 1 over I would say 1 over root 2 whole square and minus 1 over root 2 whole square. Why we did that? Just pause for a while, don't worry. So I'm just combining this one with this part. So x squared plus the square root of 2x plus 1 over root 2 whole squared, and then plus this one and minus this can be written as 1 over 2. So this is x square plus 1 over root 2 whole square and plus the square root of 2x. Look, okay, so if we talk about this, the expansion of this one, let's expand this. It's x square plus the square of 1 over root 2, that is 1 over root 2 whole square, right? And then we are having 2 times x times this, x over root 2. So this root 2 and this 2 cancels out with root 2, right? So basically we are having this stuff only. So we can write this as x plus 1 over root 2 whole squared. So this is x plus 1 over root 2 whole squared. And if we talk about 1 minus 1 over 2, so this is 1 over 2, right? So 1 over 2 can also be written as 1 over root 2 whole squared. So this is the, we can say it's completing the square method, right? So we did that way only. So we can just write this as x plus 1 over the square root of 2 whole squared and then plus 1 over root 2 whole squared. I think, is it visible to you guys? Wait a second. I think it's visible. I'm not sure. I think I should just write that again. And well, from here you can guess it out. Or maybe I should write that down again. Okay, so far we are having our I1 equals 1 over 2 ln x square plus square root of 2x plus 1. And from this, completing the square of the integrand, we got to know that it's the square root of 2 over 2 integral dx over x plus 1 over root 2 whole squared and plus 1 over root 2 whole squared. And it's something like the arctangent thing, right? So basically, let's talk about this integral. So we can say it is 1 over root 2 from the arctangent formula, and it's x plus 1 over root 2 over 1 over root 2. So this can be written as the square root of 2 arctangent of the square root of 2 times x plus 1 over square root of 2. So finally we can write this as the square root of 2 times arctangent of the square root of 2x plus 1. Well, this is basic. You can evaluate this by your own, because I just use this thing, arctangent of x. So for our case, x equals, or maybe if it is a squared, so 1 over a and x over a, right? Oh my god, I think this is 1 over a arctangent of x over a. So yeah, so for our case, x is x plus the square root of 1 over square root of 2 and a is 1 over square root of 2. So from this formula you can just compute this off. So finally we got rid of I1, and we are just going to do all the things same for I2 as well. So let's just write the final part or final result for I1. Let's just get rid of this 100% actually. So it's I1 1 over 2 ln x square plus square root of 2x plus 1, and it was the square root of 2 times the square root of 2 over 2, and then arctangent of the square root of 2x plus 1. So square root of 2 times the square root of 2 is 2. So we just got rid of this as well. And finally we are having 1 over 2, ln x square plus the square root of 2x plus 1, and then plus arctangent of the square root of 2x plus 1. Oh my god. So this much amount of thing we are having for our I1. And now let's talk about I2 with the same method. So I think I should just write that down because in case if I just forget. So our I1 equals 1 over 2 ln x square is square root of 2x plus 1, and then plus arctangent of the square root of 2x plus 1. Okay, and we are just going to look for I2 as well with the same method. We just have to multiply and divide with 2, and then we have to split this integral in 2 parts, and then we have to take a look for ln, and then for arctangent as well. I should just write the result directly, but I think if we are doing that much amount of works, then why we should just leave it as that. Let's just do that as well. So our I2 equals integral x minus square root of 2 over x square minus square root of 2x plus 1 dx. So let's just multiply and divide with 2. So 2x minus the square root of 2 minus the square root of 2 x square minus the square root of 2x plus 1 dx. Next guys, you have to do it. So it's 2x minus the square root of 2 over x square minus the square root of 2x plus 1, and then minus the square root of 2 over 2 dx over x square minus the square root of 2x plus 1. Okay. I'm requesting you to just evaluate this integral as we did the first integral, right? So this is 1 over 2 ln of x square minus the square root of 2x plus 1, and this is the square root of 2 over 2 integral dx over, we can write this as x minus 1 over root 2 whole square and plus 1 over root 2 whole square. You have to factor that out by completing the square method. So you can just do it the way we did for our first part, right? So basically I2 comes out to be 1 over 2 ln x square minus the square root of 2x plus 1, and then minus r tangent of the square root of 2x plus 1. So the way we did in our first part, we can do that with it's the same integral, but just what's the difference here, that we are having a negative and negative here, and in that integral we just had a positive on both the things, so that what made it different. I think it's square root of 2x minus 1. Yeah, it's square root of 2x minus 1, that's fine. And now I2 comes out to be 1 over 2 ln x square minus the square root of 2x plus 1 minus arctangent of the square root of 2x minus 1. So this is what we're having for our I2, and now we are good to go with the substitution here on I1 and I2, these two parts, and we would just get the final result for our integral, for our target integral, right? That was the integral of 1 over 1 plus x to the 4th. Yeah. Okay. So you know what? Like the integral of 1 over 1 plus x cubed, integral of 1 over 1 plus x to the 4th, integral of 1 over 1 plus x to the 5th. Oh my god, that is insane. Like the integral of 1 over 1 plus x to the 5th is like, oh my god, I did that, and I'm not sure whether that the answer that I got was right or wrong, because I did that on this board only, right? On these 3 boards. So the answer I got was even not filling in this board. I used these 2 boards to fill my result, the final result. So you can imagine that how crazy that integral is. So this is the power of 1, because if it is not there, it is a child's play, the integral of 1 over x to the 4th. So yeah, that is what it is. So our I equals 1 over 2 root 2, and I1 we evaluated as 1 over 2 ln x square plus the square root of 2x plus 1, and with a positive sign arctangent of the square root of 2x plus 1, and yeah, and with a negative 1 over 2 root 2 as the factor, we are having 1 over 2 ln x square plus the square root of 2x plus 1. Oh, I'm sorry, it's negative. And negative arctangent of the square root of 2x minus 1. Now, I can just consider plugging this 1 over 2 root 2 out of this big chunk of things, right? And I'm just going to consider multiplying this negative into this parenthesis. So this is going to be positive and this is going to be negative 1 over 2, right? And this is going to be positive as well. So basically I equals 1 over 2 root 2, and that big parenthesis 1 over 2 ln x square plus the square root of 2x plus 1 plus or I think I should consider 1 over 2 taking out of this as well, because these both ln terms are having 1 over 2 in front, and with a negative sign here we are having ln x square minus the square root of 2x plus 1, right? And this part ended here. And now if we talk about the arctangent part, so that is arctangent of the square root of 2x plus 1 and plus arctangent of the square root of 2x minus 1. So this is what we are having so far. And this is a positive here. Yeah. So using the basics of natural logarithm, we can just divide this with this one, and we can consider writing a common logarithm there, right? A natural logarithm. Now let's talk about this arctangent part here. So basically we have a formula here. Arctangent of A plus arctangent of B equals arctangent of A plus B over 1 minus 8B. So for our case, A equals the square root of 2x plus 1 and B equals the square root of 2x minus 1. So basically, arctangent of the square root of 2x plus 1 plus arctangent of the square root of 2x minus 1 is gonna be arctangent of the square root of 2x plus 1, A, right? And plus the square root of 2x minus 1, B, over 1 minus the square root of 2x plus 1 times the square root of 2x minus 1, right? Okay, so now we got rid of this negative and positive one with each other, and we are having on the numerator. Okay, so yeah, I think I should just combine these natural logarithms with each other, and then let's proceed with this one actually, because so let me just write that down over here. So basically our I is coming out to be 1 over 2 root 2 times 1 over 2 ln x square plus the square root of 2x plus 1 over x square minus the square root of 2x plus 1, right? And then we are having this arctangent part. So if we are just going to evaluate that, okay, so if we are just going to evaluate that here, let me just evaluate. So it's arctangent of the square root of 2x plus the square root of 2x, that is 2 times the square root of 2x, right? And over, so this is A plus B and A minus B being multiplied to each other, so that is A square minus B square. So it is the square of square root of 2x, that is 2x square, and minus 1, so that is gonna be minus 2x square minus 1. So it is arctangent of 2 root 2x, right? And it's 1 minus 2x squared and plus 1. So this is going to be arctangent of 2 times the square root of 2x over 2 minus 2x squared. So this 2, and this 2 getting cancels out, and we are finally having our arctangent part to be resolved as the square root of 2x over 1 minus x squared. Okay, so basically here we have to plug that part, that is arctangent of the square root of 2x over 1 minus x squared, and this parenthesis as well actually, because we are having we have to multiply the 1 over 2 root 2 in all the cases, like the rest of the cases here. And now let's just multiply it in this parenthesis. Finally guys, we just did that, and it was a great journey, and we are here with our final result, that is I integral of 1 over 1 plus x to the 4th dx equals 1 over 4 root 2 ln x squared plus the square root of 2x plus 1 over x squared minus the square root of 2x plus 1. And then if we multiply this with that arctangent as well, so it is 1 over 2 root 2 and then arctangent of the square root of 2x over 1 minus x squared and plus c. So this is the final result that we have solved and we have got. Yeah guys, I know that it was a pretty difficult or maybe lengthy. It wasn't difficult at all, but we just have to take care of a lot of things, like we have went through this this factorization, and then we had went through the partial fraction decomposition of these parts, and we have to care about all the a, b, c, d, and then we have to just care about plugging a, b, c, d, and then through which we have to just compute all those integrals as we did. So yeah, it was pretty difficult to evaluate, but still it consists of a lot of things to learn from this. But if you want something easy, so you can consider watching the video which I have uploaded, or maybe I would just provide the link of that video in the description box of this video, right? In the description box of this video. So that was quite easy to evaluate. We did some manipulations, but that was not difficult, something like that. So yeah guys, if you got to learn something from this video, please make sure to like, subscribe and share. And if you have any kind of doubt so far, you are free to ask me in the comment section. I'll make sure to reply as fast as possible over that. And yeah, stay tuned for the next video guys. Take care, goodbye, love you. And I'm bringing a lot of things for you guys, so I would request you to just come up and watch my all the videos that is upcoming, and maybe you can just consider watching my old videos because they also consist of a lot of things over there. Goodbye guys, love you.